Okay, so to just pick up from where I left off, we agreed that it can be concluded that there is a difference between the mean fat content of the two types of meat, and that's really simply because we've rejected our null hypothesis. So, alright, so now it wants us to calculate a 95% confidence interval for the mean fat content per 100 grams from the wild meat. So I'm going to use my calculator to do this. So if we exit out of that, and then we go F4, Z, 1S, make sure it's data, confidence interval is 95%, standard deviation is 0.4, X bar is 2.4 and N is 50. The smart thing about this Casio is that it's already picked up what we've entered for the other problem, and it's used that to find, or it's already entered the values in, so it's pretty smart. So that means that we're going from 2.29 to 2.51. So because this is only worth 1 mark, 2.29 is less than or equal to mu, which is less than or equal to 2.51. And probably just what we should do is say that the 95% confidence interval for the mean fat content from the wild meat is, and it's that, so 2.29 is less than or equal to mu, which is less than or equal to 2.51. Okay, so on an advertisement is placed in a consumer magazine that says on average from the wild meat contains at least 5% less fat than farm grown meat. Do you think this advertisement is justified? Explain your answer. So, well, let's start by saying that the mean fat content of farm grown meat is obviously going to equal 2.7 grams per 100 grams. Now we agreed from A part V that there is a difference between these mean fat contents. So the fact that it contains less, we're agreed that there is a difference from our hypothesis testing, but they wouldn't have really got us to calculate a confidence interval without that being useful as well. So if from the wild meat contains at least 5% less fat than farm grown meat, if it contains 5% less fat, then it's going to contain 95% of 2.7 grams, so it's going to contain at least, it's going to contain at most 95% of 2.7 grams. So at most from the wild meat is going to have to contain 95% of 2.7 grams of fat, which is equal to 2.57 grams. And now if we construct just a brief sort of number line, and I might just pause the video while I construct it. Okay, so that's our number line that we're going to use. So the confidence interval that we calculated goes from 2.29, so about 2.3, so about halfway between those two, to 2.51. So it goes from about there to there. I'm just going to make that a bit bolder so it's easier to see. So that's our confidence interval. And now if it contains at least 5% less fat, then it's going to contain at most 95% of 2.7 grams, which is 2.57. So that value is about out here. And so what you can see is that the mean the mean for from the wild meat it occurs somewhere within this interval, but for this claim to be true, it could occur from here. It has to be here or less than that. And so because our mean is clearly less than this value here, because it occurs within this interval, because the whole interval is less than this value here, then we can say that that claim's true. So if we just really from the diagram below, we note that the mean content from the wild meat is always less than 95% of the mean fat content within farmed meat. Hence the claim that from the wild meat contains at least 5% less fat than farm-grown meat is justified. Okay, so I hope all this makes sense. Please ask me if it doesn't within class. I'll just let you finish copying that down. So the homework is going to be to do hazy exercises 7H1, 7H2 and 7H3. I believe it's 7H3, which talks about the idea of sort of doing it in a reverse way. So talks about that 5% area outside, and I think it gets you to look at a different way of doing hypothesis testing. What I would recommend is that you just stick with this standard way though, because that's fine and that will cover you for all cases in the exam. Doing this 95% confidence interval, at least it should cover you for all cases in the exam, from what I understand. So yeah, hopefully that makes sense, and work through those hazy exercises to get good practice before your test next week.